This video was produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. Before continuing, please see video entitled Scatter Plots and the Line of Best Fit. Correlation is the statistical method we use to determine if there is a linear relationship between two variables and if so, the strength of the relationship. The relationship strength is represented as a number called the correlation coefficient and has to be a number between -1 and 1 inclusive. We use the letter or to stand for the correlation coefficient. So or has to be equal to a number between -1 and 1. I'll use a number line to talk about the correlation coefficient. No correlation or relationship between variables is represented by or equal to 0. Perfect positive correlation is represented by +1, and the perfect negative correlation is represented by -1. What do I mean by positive correlation and negative correlation? A positive correlation is a relationship between two variables where if one variable increases, the other one also increases. For example, height and weight. Taller people tend to weigh more than smaller people. A negative correlation is one where when one variable increases, the other decreases and vice versa. An example of this is as the winters get colder, the heating costs for a house increase. Now, going back to our number line, if there is a strong, positive, linear relationship between variables, the value of or will be close to 1. If there is a strong, negative, linear relationship between variables, the value of or will be close to -1. If there is a weak, positive, linear relationship between variables, the value of or will be close to 0 on the plus side, and if there is a weak negative linear relationship between variables, the value of or will be close to 1 on the negative side. To summarize, weak negative relationship or close to 0 and negative, example -0.1. Weak positive relationship or close to 0 and positive, example 0.1. Strong negative relationship or close to -1, example -0.85. Strong positive relationship or close to +1, example 0.9. Higher level students need to know how to calculate the correlation coefficient on the calculator. Owing to the fact that everyone has a different model and brand of calculator, I have not done this. I recommend Googling correlation coefficient and your make and model of calculator to find out how to do this. Now we will look at correlation in relation to scatter diagrams. The correlation is high or strong if points are close to a straight line. The correlation is low or weak if points are not grouped close to a straight line, i.e. they are more dispersed. Try labeling the 5 diagrams with the 5 labels in the lower right hand side of the slide. Let's take a look at the first label, strong positive correlation. As the correlation is strong, the points have to resemble a straight line. As the correlation is positive, as x increases, y increases. So this means the top diagram on the left is the strong positive correlation. For the strong negative correlation, the points also have to resemble a straight line, but this time, as our x values increase, our y values decrease. So this means the bottom diagram is strong negative correlation. For weak positive correlation, we need the scatter diagram to show x values increasing at the same time as the y values increasing. However, as this is weak correlation, the points need to be more spread out than a straight line. Hence, the weak positive correlation label goes here. For weak negative correlation, we need one variable to increase as the other variable decreases. We also need the points to be more spread out than a straight line. In this case, this top diagram is the weak negative correlation. The last label is no correlation. This means there is no relationship between the scatter points. On this last diagram here, we would not be able to fit a straight line anywhere, either in the negative or positive direction. Therefore, this is the diagram that represents no correlation. Now let's remove all the correlation labels and start again using only correlation coefficient values to label our scatter diagrams. Try pausing the video and labeling the diagrams yourself. The first correlation coefficient is 0.01. As this is close to 0, it represents no correlation. Therefore, it's this scatter diagram. The second correlation coefficient is 0.83. As this is positive and close to 1, it is a strong positive correlation. So this diagram. The next correlation coefficient is minus 0.35. It's negative and closer to 0, so it represents weak negative correlation. The next correlation coefficient is minus 0.9. This is close to minus 1, so it represents negative strong correlation. So this bottom diagram here. And the last one is 0.24. It is close to 0 but positive, so therefore it represents weak positive correlation. We have one more item to cover on correlation. Correlation does not imply causality. Causality is where there is a cause and effect relationship between events. In the case of variables, causality is where one variable causes a change in another. In comparison with correlation, variables may increase with each other or have an inverse relationship where one increases and the other decreases. However, the change in one variable is not causing the change in the other variable. For example, heating costs in winter and the temperature in winter have both a causal relationship and correlation. In comparison, sale of sun cream and sale of sun hats have a strong positive correlation. However, one of these variables is not causing the other variable to increase. There is no causal relationship between sale of sun cream and sale of sun hats. That concludes the session on correlation.